Welcome back. I am happy that you're here. I'm happy that you logged in. This is great. You are where you need to be because you're on Edmodo. That's all we need for this course. When it comes to inventions, we're going to talk about some of the inventors and the things they invented. It's going to be pretty great. This video is so short. In fact, it's this long right here. It's all we're doing for week one. We're doing a video and you're going to take a quiz on that video. The following weeks, we're going to have probably 2 videos a week, but they're going to be short, sweet. You're going to take quizzes. We're going to move on. It's going to be pretty great. Let's get started.
Morse, Joseph Henry, and Alfred Vail invented the electrical telegraph system. It was the first system that allowed communication over great distance.
So the key thing with that, it is going to allow communication over great distances. The only issue with that is that they don't have a way to read it. So what they are really going to need to do is they're going to need to invent some way to read through that. So that's going to be the major issue at first. Let's keep on going here.
This meant that you wouldn't be able to communicate using voice or text, so a new way of getting messages across the world was needed. A code was developed by none other than Samuel Morse to translate electrical pulses back into the original message. The rules of Morse code are as follows. Each dot serves as the basis of time for the code. 1 dash is equivalent to the length of 3 dots. After each character, there's a silence that is equivalent to the length of 1 dot. This relative timing allows for Morse code to be easily sped up and slowed down, all while keeping the same pace.
Okay, I know, that is riveting stuff, but why is it important? It's so important because up until this time, say you wanted to send a text message to your friend that's up in Mrs. Anderson's calc class. Awesome. But there's no such thing as text. There's no such thing as calls. There's no such thing as any of that. You would actually need to go up there and either take a piece of paper and hand it to them or yell it to them. That's great, but that's 1830s. Let's get way past that. Now we can send text messages. We can send video calls. Heck, you guys are learning right now over the internet, and the basis of that communication over distances is Samuel Morse. It's fantastic. So he has to invent things to then relay his code. Let's take a look at what those look like, those telegraph machines. What do they look like? So if you take a look, we saw that there's that series of dots and dashes. We know every single dot is just that single count, and then a dash is holding it for a count of 3, and there's a space between each one. I like to think about it as turning on and off a light bulb, like that bottom left one right here. This is what it's all about, because really what they're doing is you are turning on a light switch on and off in a relay system miles away, hundreds of miles away, across the Atlantic Ocean away, which nowadays we don't think of as a crazy idea, but this was huge. And how are we going to take that and relay that and make it a code so we can actually learn that information? That's what Samuel Morse does. Monumental. Cyrus Field. Well, Cyrus Field takes this idea and expands on it. Field's like, I can expand on that. I'm not just going to have them relay information from DC to Philadelphia, which is awesome. Don't get me wrong. But Cyrus Field says, take it one step further. I would really like to relay information from DC to London. Wouldn't that be fantastic? But how do you do that? Do you have buoys where they're floating? Right? That's not really going to work. We don't have this whole like, we're just going to fly it through them. No, that's not going to work. So what are we going to do? Well, he decides that maybe we can lay it at the bottom of the ocean. And that is exactly what he does. Here's a drawing of them doing that. So you see that they have a trench dug here on the land. And then they're going to have those buoys that are going to float it out. And they can slowly lower it into the ground. And they're going to have ships that are going to take it across. Here's what it would kind of look more like nowadays. So you're going to relay those buoys. So it's going to make it to where there's not extra stress in the cable. And they're going to slowly lower those down. And then now we're going to actually have a jet. I'm going to show you a water jet. I'm going to show you what that's going to look like here in a second, what it really looks like nowadays. Oh, and of course, here's a video of a shark trying to eat a cable because, well, why not? Okay, so I know what a lot of you are thinking. A lot of you are thinking, okay, this is great. Awesome. 1830s, great. But we're still doing this today. We're still using transatlantic cables today for phone calls, text messages, and emails. So let's take a look at how that's being used right now.
what am I standing on right now?
You're standing on fiber optic cable that's going to be laid from here towards Brazil.
This is how worldwide communication begins. Jeff Sanders is a captain at TE Connectivity Subcom, which calls itself the world's largest provider of under-ocean fiber optic cable.
They're coiling it the same way they did in the 1800s.
He gave us a rare view of more than 900 miles of cable spooled tightly by hand in one of 3 side-by-side tanks aboard the ship anchored in the port of Newington in New Hampshire. So the cable we're walking on right now will be under the ocean carrying my phone calls?
Yes, it will. It's a good chance any call you make to South America in the future could be on this exact cable for the next 20, 25 years.
Robots take over from there, diving to a depth too deep for humans. The machines use water jets to create a trench, allowing the cable to sink into the seabed and become buried.
95% of all telephone and data is transferred over submarine cables.
Not satellite. It's what allows us to rely on instant everything. Phone calls, banking, web surfing, email, streaming video, and other communication.
Every case?
And it all began 150 years ago.
We have here samples of the early cables from the 1850s.
This is what the first permanent cable looked like under the Atlantic.
Absolutely.
Barney Finn at the Smithsonian's National Museum of American History helped string together an exhibit commemorating the 150th anniversary of the first permanent transatlantic cable, and the man who assembled the financial, political, and technical prowess to make it happen, entrepreneur
Cyrus Field. Okay, that's a pretty sweet idea. In fact, the idea that we're going to drop a cable to the bottom of the Atlantic Ocean, where they could not dive at the time, to relay information to Europe just to speed up time. It is monumental for inventions. So cool. But how can the general person talk over long distances? How can you do that? Well, that's what our next guy looks at. We have Alexander Graham Bell. And he is going to be the guy that's going to invent the telephone. Now, we're not going to spend too much time on this. I'm sure you've heard that Alexander Graham Bell invented the telephone. Now, what's kind of cool, though, is that they were testing different frequencies and having voices carry over telephone lines. Now, here's the key thing with that. First word said, you'd think it'd be great. You'd think it'd be, Neil Armstrong stepping off saying one small step, right? It'd be so great planned out. Instead, what happens? Well, Alexander Graham Bell accidentally spills battery acid on himself. And his assistant is in the other room. And so he yells out to him, "Mr. Watson, come here. I want you." And that is the first voice spoken over telephone. But wow, missed opportunity. Okay, the next one, Henry Ford. Now, this is a major misconception about what he did. I can tell you what he didn't do. He didn't invent the car. You don't want to have one worker trying to build a car. Instead, how about you have one worker trying to install seats? Okay, cool. That's my job. 4 bolts all day long. I can make that happen. Next one, boom, other seat. Great. Next one, we're doing engine. It's all separate. So you have specialists who know what they're doing and they have repetitive tasks that they can do it over and over. This is a couple GIFs showing those lines pumping out of the factories. He wants to make an inexpensive and quick to produce car, which he is able to do. Hence the reason why we still have Ford vehicles today. You see them just pumping out of those factories right there. The whole goal is to minimize cost and to speed up production. And if we can do that through using assembly lines, that's what we're going to do. So we can see a whole car being built. And you can go online and you can take a look at cars being built in time lapse, and you can see how fast some of these go through. See that the car is now painted and they are going to install the interior. As you see, those workers, they have one job there. They're working on install of their one piece, and then it's moving on to the next person. And we have a brand new BMW. Fantastic.
The ranking of things to worry about, Skynet coming and taking over, doesn't even rank in the top 10. It distracts attention from the more urgent things, like, for example, what's going to happen to jobs.
Let's take a look at the Amazon facility.
For a glimpse into the future, consider one of the largest companies on the planet, Amazon.
Amazon has tremendous scale.
We have fulfillment centers that are as large as 1.25 million square feet. That's like 23 football fields. And in it, we'll have just millions of products.
You see, today, the major two things we talked about were inventions. And those inventions, first we hit it off with Samuel Morse, who is going to invent the telegraph machine. And then, well, with the help of Alfred Vail and also the help of Joseph Henry. But then we're going to see that he also goes through and invents the Morse code to actually make it to where they can communicate over those lines. It's fantastic. And then we see Henry Ford is going to do production style system. Alexander Graham Bell is going to use this idea of communicating over long distances, but he would like to use actual voice. So we see these major advancements and inventions. All you need to do now is take the very short quiz that I have waiting for you. Go hit it up. It's fantastic. You'll be sorry if you don't do it. I promise. It's so quick. Make it happen. I hope you guys have a great week. I hope you are safe and you are practicing some distancing from other people, especially your friends. That would be great. I see way too many people just hanging out right now. What are you doing? Stop. I would like to leave my house sometime. I would like to come and see you guys. So for us to do that, we got to be safe. Other than that, I hope to maybe see you at office hours. I hope to maybe see you turn in some homework. And by homework, I mean that quiz. That's all I want. Other than that, have a great time. I miss you. I'll see you soon. Bye.